In this video, I will show you how to check whether the given number is Armstrong number or not. So first I will open the editor and creating a new source file. First include the relevant library files that are required for our application. So include stdio.h. Then start the main function. Here we need to include declaration part and logic part and displaying the output part. First, I will explain what is an Armstrong number. If you see this one, there is a sample number 153 is there. Cubing the individual digits and adding them, again we will get the same number. Suppose 153, the individual digits are 153. Cube them, 1 cube, 5 cube, 3 cube. Add them. So 1 cube plus 5 cube plus 3 cube. That generates again 153. The same number again we will obtain the same number after applying the cube operation on the individual digits and sum. Then it again generates the same number. Those numbers are called as Armstrong numbers. That is the property of the Armstrong number. Applying cube operation on the individual digits and sum up. Again, if you get the same number, then that number is, we can conclude that Armstrong number. If any number that satisfies this property, that is called Armstrong number. Now our job is we need to read an input number from the user and we need to capture the individual digits and apply cube operation on them, and also parallelly we need to calculate the sum of them, and the sum we have to store in a variable, and that sum value is compared with the original input value. If both are matched, then we can declare that given number is Armstrong number. Otherwise we can conclude that given number is not an Armstrong number. And in my program I'm going to use this logic, that is I will read a number, that number is n. I will check that whether it is greater than 0 or not. Then I will apply r is equals to n modulus 10. N modulus 10 is nothing but 153 is our input number. 150 in first iteration, what is n value? 153. 153 modulus 10 means 10 15 is 150 and remainder is 3. So r is assigned with 3. R means remainder. Is a variable, name of the variable that holds the remainder. Now, according to the formula, sum is equals to sum plus r cube. What is sum initially? In the first iteration, initially sum is 0. What is our value of r in the first iteration? Just now we calculated the r value that returns 3. So 3 cube. So 3 cube means 27. This is actually, this is not 3, actually this is here 27. So 27 plus 0, the sum value here is 27. Now, what is next one? N is equals to n division 10. N is equals to n division 10. N division 10 means what is the latest n value? 153. 153 division 10 means quotient is 15. Quotient is 15. Now, after this statement, again the loop, the control will come back to this loop. Again, the starting point of the loop. Now, what is the latest value of n? 15. Is 15 is greater than 0? Yes. Condition satisfied. Then the execution flow will enter into the inside the loop. What is the first statement? R is equals to n modulus 10. What is R value? The latest n value is 15. N modulus 10 means then it returns remainder. So 15 10 means 10 5 10 ones are 10. Remainder is 5. Now what is sum value? What is the previous sum value? That is 27. What is the latest R value? That is 5. So 27 plus 5 cube. 5 cube means 125. 125 plus 27 results 152. Now after that n is equals to n division 10. Our n value, latest n value in the second iteration is 15. 15 division 10. 10 ones are 10. That means 1 is here quotient. Now after this again the control will come back to the beginning point of the while loop. Now what is the latest n value? 1. Is it greater than 0? Yes. Is it greater than 0? So condition satisfied. Then it calculates the n modulus 10. That means 1 modulus 10. 10 zeros 0. Remainder is 1. So R value is 1 here. Now sum. What is the previous sum value? The previous sum value is 152. So that number plus R cube. What is the latest value of R? 1. So 1 cube. 152 plus 1. That results 153. Next. N is equals to n division 10. What is the latest n value in this third iteration? 1. 1 division 10. 10 zeros is 0. Remainder is 1. But quotient is 0. Now after this again the control will come back to the beginning point of the while loop. Now 0 is greater than 0. No, 0 is equals to 0. So condition becomes false. Then it will come out of the loop. Once it will come out of the loop, we are comparing the last final sum value, that is 153. That is 153. That value we are comparing with D. What is D? D is nothing but we are maintaining a copy of original number n into a duplicate variable D. That is called D. Why? Because on input value n we are applying so many operations. Finally the n is holds 0. If you observe this one, n is holds 0. I will change the color so that you can get this one. Initially n is 153, but at last iteration n becomes 0. So we cannot compare n with sum. That is the reason we are maintaining a copy of the n into a variable called D. Now our input is holded by a variable called D that we are comparing with the final value of the sum. If both are matching, then we are displaying the given number is Armstrong number. Otherwise, we are displaying the given number is not an Armstrong number. Not an Armstrong number. So using this logic, we are going to check whether the given number is Armstrong number or not. Now, first we need to declare an input number, that is n, and also we need to declare a variable called sum, that is initial with 0, and we need to hold a remainder, that is held in a variable called r. These are our basic input values. First we are asking the user to enter a number. Enter a number. After entering the number, we are providing a message. Then we are using scanf function. We try to collect that input from the user. As it is an integer, format specifier is %d, and the variable name is n. So we have to use here ampersand n. That is one. And after that, yeah. So here we need to start our logic. Just now I explained the logic. We are checking whether the entered value is above 0 or not. If it is above 0, then we start calculating the remainder. How do we apply the calculate the remainder? Using percentage symbol on the input number n. Then each time we are going to calculate some value along with the, after capturing the individual digit, we are applying cube operation. The individual digit is captured in the variable r. We are applying the cube operation. Every time we are trying to decrease the number of digits. That can be done with the help of n is equals to n division 10. After come out of the loop, we will keep a condition, and I forget to here, we need to maintain one more variable, duplicate variable D. After assigning value for n, that is assigned for duplicate variable D. Now this duplicate variable D, that means our initial input, is compared with the sum. If both are matched, then we will conclude that given number, I will print the number value. Okay, given number is Armstrong number. Armstrong number. So we need to print that number. That number is stored in D. I will copy this line. Now I will include the else. If both are not mapped, then we need to display given number is not an Armstrong number. This is the logic we have to use to check whether the given number is Armstrong number or not. So I will save this program, Armstrong demo.c. Now we need to compile. While compiling, find out number of errors. There are no errors. Errors are 0. So successfully compiled. So no syntax errors in my program. So for in my example, just I given 153. So it is supposed to generate given number is Armstrong number. For example, if I clicked on, if I given some other number 123, 1 cube plus 2 cube plus 3 cube, how much? 1 cube means 1, 2 cube means 8, 3 cube means 27. So 27 plus 8, 35 plus 1, 36. It won't equals to 23. So in this case, else part will be executed. So given number 123 is not an Armstrong is printed. So we are checking both successful case as well as unsuccessful case by assigning two different inputs for the n. First time I assign 153, next time I assign 123. 153 satisfies the Armstrong number property, whereas 123 is not satisfied the Armstrong number property. So in this way, we can check the given number is Armstrong number or not.